Hi guys, welcome back to my YouTube channel Code Ground, the battleground of coding. So today I'm going to solve the daily coding challenge of October 4th, that is container with most water. Okay, so let's see what the question is. Yeah, uh, you are given an integer array height of length n. Okay, there are n vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma height of I. Okay, find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, so let's start. So let's visualize first. So let's suppose we are having two lines. One is of height h1 and the other's height is h2 and the distance is d between them. Okay. So the water can only be stored like this because the height of the container depends on the minimum height of the left and the right bars. Okay, because if the container's height is h2, then the water will overflow. Okay, got it. So what is the area of the water? The area of the container is d, which is the distance into minimum of h1 and h2. Got it. So, in this way, from the given integer array, we have to find two lines such that those two lines make a container and the area of the container is maximized. Okay. So for this, what can we do? Uh, Basically, we can have two approaches. One is brute force approach. Second one is two pointer. Okay. So let's see what this brute force approach is. Okay. Okay. So let's suppose we are having lines like this. Okay. So let's suppose the length of this is 2, the length of this is 4, the length of this is 3, and the length of this is 1. So we are going to compare each and every line with the other line, with the other line. So we are basically going to make two combinations. So there are four lines, so we'll get four C2 lines. This is so four C2 combinations, that is six combinations. Yeah. So we are going to compare each and every line with the other line and see uh, which container can hold the maximum amount of water. So the complexity of this would be O of n square, where n is the number of lines. So uh, for larger n's, this would not be very great solution because we would get a problem of time limit exceeded. So once let's code the process of n square and let's see. So int n equals to height dot size. Okay. For int I equals 0, I less than n, I plus I plus plus. For int j equals 0, j equals we can just do I plus 1, j less than n, j plus plus. Okay. So yeah, we'll have the max area as 0. Uh, int area equals to what is the area? The area will be uh, j minus I, which is the distance into min of height height of I, comma h height of j. Okay, so this is the area, and max area will be max area and area. Okay, and let's return the max area. Okay, okay, I did not write int. Okay, okay, this solution is accepted, but let's submit. Yeah, so as expected, this solution is giving a problem of time limit exceeded. So this is because for larger n's, see here n is in the order of 10 power 5. So for larger n's, this may not be feasible because uh, in the n square solution, 10 power 10 iterations may be required. So this is not a good solution. So what can we do? The next approach is the two-pointer approach. Okay, let's see what the two-pointer approach is. Yeah, we are having four poles. Okay, and in the two-pointer approach, we'll maintain two pointers. One is the left pointer, and other is the right pointer. Okay, the left pointer will be at the leftmost index, left pointer, and the right pointer will be at the rightmost index. This is the right pointer. So we will be going on bringing the left pointer to the right side and the right pointer to the left side until we find the container with the maximum area. So how are we going to do this? So let's understand in a simple way. So in order to maximize the area of the container, we need to maximize two things. One thing is the width of the container. The width of the container is the distance between the two poles. Okay. And the second thing, we need to maximize the height of the container. The height of the container is height of the minimum pole. Okay. So, but in this solution, we can't maximize both because if we are looking for the better height, we are going to move either to the left or to the right. So, while moving either to the left or to the right, maybe the height may be increased, but the width will be decreased. So we can maximize only one in this case. So how are we going to do that? It is simple. Uh, we know that we are going to shrink the size of the container's width. Okay, so our approach should be to maximize the height. Okay, so what are we going to do to maximize the height? See, uh, the thing is simple. If the left pole's height is greater than the right pole's height, so the right pole's height is less. So what are we going to do? We are going to do right minus minus, so that we will get a better right height. Or else, if the left height is less than the right height, we are going to do left plus plus, so that the left height will be maximized. So by doing this, get uh, we'll get a container with the most suitable maximum height. So yeah, this is the approach. Uh, I hope this approach is very clear. So let's get into coding. Yeah. So we will have two pointers, int L, which is 0, and int R, which is n minus 1. So for that, int n equals to height dot size. Okay. And we'll have int max area equals to 0. Okay. While left is less than right. Okay. Because left should be always less than right. Okay. Uh, while left is less than right, we are going to calculate the area. Int area equals to what is the width? Right minus left into min of height of L, comma height of R. Okay, this is the area we've got it, and max area equals to max area, comma area. Okay, and what are we going to do if height of L is less than height of R? L plus else R minus, yeah, and return max area. That's it. Yeah. So now let's submit the solution. Kudos. We've done it. Yeah. So this is how we should solve this problem using the two-pointer greedy approach. Yeah. And that's it for today. Please do like, share, and subscribe my channel, guys. Uh, we'll be overwhelmed to receive your support. Thank you very much. Bye.